All right, so in this example, we want to use the alternating series test to determine if this series converges or diverges. So here's the information about the alternating series test. I took a snapshot out of the book. So if we have an alternating series, if we look at just the part here, the BN, without the negatives, if we look to see if those terms decrease for all n's greater than or equal to 1, that's the first condition that we need. And if the sequence of the bn's approaches 0, then we can, by the alternating series test, we can say that the series converges. So to save myself some arithmetic, I put this in on my calculator. So I entered this in. Now, keep in mind that when I enter this in as a function on the calculator, it's going to show a continuous function. But keep in mind, we're only looking at the discrete values of x is 1, 2, 3, 4, 5. So we're not going to worry about the parts in between. Now, when I graphed this, and I had to adjust my window and play around with it a little bit, but when I graphed it, this is what I got. So K, or in the homework assignment, it's labeled as K, but I used X on my calculator. When X is 1, it's going to be up here, okay? And then as it comes down, it's going to keep bouncing back and forth, and then it's going to get closer and closer to 0. So we can see that the sequence is approaching 0. So that condition holds true. However, what happens is if we then go look at the table, I'm going to go look at my values now to see if each of those values are decreasing, ignoring the pluses and minuses, just looking at the absolute value of the terms. That does not hold true here. So, for example, if I look at term 3, that's going to be 1.5 e to the negative 4. If I wrote that out in standard form, it would be 0.00015. Now, if I go to the fourth term, that's 4e to the negative 4, ignoring the sign. Remember, we're doing this for the absolute value of the terms. 4e to the negative 4 is 0.0004. And that's bigger than this one here. And you'll see that it doesn't consistently decrease. It bounces around a little bit as you start looking through these values. So we can't say that all the terms, ignoring the signs, that all the terms are decreasing for all values of n greater than or equal to 1. So in this case, we cannot use the alternating series. It doesn't, the conditions aren't met. So if I were to answer this question, let's see, I would choose this one here. The alternating series test does not apply because the absolute value of the terms are not decreasing.